Hello everyone, in this video I'm going to go over the October 30th class notes with you. So before you open up the class notes page, which is linked on Canvas, make sure that you download the spring2024.txt file. Last time some of you that have Macs were having trouble with that file. I found out that was to do with Canvas, so this time I linked it from my Google Drive, so it should work for you guys to download it this time. Just go ahead and open it, and then you'll be on my Google Drive, and you can click the download button there to download it. Okay. So now if you'll go ahead and get the notes file open, and I'll go over this with you guys. So the first thing I wanted to go over was how to write to files. We went over reading from files last time, but actually writing to a file is even easier than reading a file because there's nothing to loop through. So let's look at some examples here. If we look at the code block here, you open the file in the same way that you do when you're reading the file, but you have to have a second argument here. And this argument, if you want to write to the file, needs to be a W, just lowercase w. And then, of course, for the first argument, you still have just the name of the file. And then you're going to have this F equals part at the beginning like before. That is the file handle. Then when you want to write something to the file, you do the file handle dot and then write, and then just put whatever you wanted to put into the file as the argument to that method. Okay, so this is going to write the string blah, blah, blah to the file, and then it's going to write the string here to the file. And then lastly, you're going to close the file, and note that the file is not actually updated until you do close. This is actually kind of important that you understand this because if you're using a writing to file for like calculating a really big data set or something like that, sometimes this could be bad if your computer crashes before you actually close the file. You could lose all of the data. So something to think about if you guys go in the direction of data science is closing it frequently and then reopening it to make sure changes are saved. But not a big deal for right now. Another thing to be aware of when you are writing to files is when you call open and then the file name with that W argument, it will either create the file if it doesn't already exist, or it will replace the file if it does already exist with a blank file. So you could lose whatever was in that file before if you're not careful. If you want to actually open a file and then append text at the end of it instead of overwriting that file, you can use A for that second argument instead. It's A for append. And then whatever you decide to write to the file will go at the end of the file. Okay, so let's go ahead and run this code here and see what happens. Okay. All right, so I went ahead and ran, and you're not going to see anything here. There's no results that print out or anything. But if you open the file over here, you should now see in the file list here, test.txt has been created. And if we open it, it does contain those two strings, and there's no space between them. There's no line break or anything like that. So if you want to put line breaks, you have to add those in yourself. So for example, I could put a line break at the end of this line like that, and that would go to a new line. Also, when you're using Google Drive and Google Colab, you need to like reopen this file folder thing here to see when new files appear. It doesn't just like automatically refresh. Okay, if any of you wanted to do this on Replit, I know some of you guys use Replit for these coding exercises. Let me show you how it works on Replit. I'll just paste this code in here and run. And you see the file appears right over here, test.txt, and you can open it as well. Okay. All right. So next thing I wanted to do was an example where we write some search results to file. So this example is going to search through the lines of the spring2024.txt file, and it will write the lines containing the substring CSCI to the file spring2024-CSCI.txt. So for this one, you need to make sure that you have that spring2024.txt file uploaded in the files area over here. So I'm just going to open that and click the upload to session storage icon here. And I'm going to upload the spring2024.txt file. Okay, and then Google is just warning me that like when I close this notebook, this notes notebook, that the files that are listed over here are going to just be dumped and deleted. Okay, but that's fine with me. Okay, so now I'm going to close that. Okay, so in this example here, I have two file handles. I have F1 is the file handle for the Spring 2024 file, and F2 is going to be the file handle for the new file that I'm creating, Spring 2024-CSCI. So I'm going to open both of those, and I'm going to open the new file in write mode. Then I'm going to loop through the lines in the first file, the Spring 2024.txt, and if the string CSCI is in that line, then I'm going to write that line to the new file. Okay, and then at the end, I'm just closing both files. So let's go ahead and run that and see if it works. Okay, so nothing appears here, but if I open my files list over here, I now have a new file called Spring 2024. Let me double click it. And over here, I can see, oops, okay, maybe I can see. Let me see. Hold on. Let me reopen it. Yes, okay. So, whoa, why does it keep disappearing? I think these lines are like super long, which might be why it keeps disappearing. Let me try downloading it and open it in my own text editor instead. Yeah, okay, so now you can see that the lines that are in here are all of the CSCI classes that are being offered next semester from 181 all the way down to CSCI 500. Okay, I guess this Google text viewer here is not very good since it made my lines disappear. Oh well. You can also do this example in Replit if you want to, and it should work just fine in there as well. Oops, didn't quite copy it. Try again. Oh, I hit Function C. Okay, Control C. Let's try that. And we can run that. And, oh, right. That's right. If you're using Replit, you need to also upload the Spring 2024 file over here as well. Let me see, how do I do this? Upload file. Go. Okay, let me try this again. Okay, and now we see the Spring 2024 CSCI file has appeared over here. All right. Okay, so that's pretty much all I wanted to teach you guys about writing search results and writing anything to a file. And the next thing is just a little exercise for you guys to try there at home. In the next cell, try writing a program that searches through the lines of Spring 2024.txt and write the lines containing the substring engl to a file called Spring 2024 engl.txt. So go ahead and pause the video here and try doing that, and then unpause it when you're ready to see a solution to this. Okay, so assuming that you went ahead and did that exercise, here is one way to do this. There's multiple ways, but this is one way. So we're going to need one file handle for the Spring 2024.txt file. So I'll call that F1. And then we're going to need another file handle for the new file. I'll call that F2. So we want to name the new file Spring 2024-engl.txt. And we need to put the second argument W to make sure that the file is open in write mode. Then we're going to loop through all the lines in the first file, like this. And we're just going to check if engl is in each line. And if it is, then we're going to write that to the second file. We're going to write the line to the second file. Okay, and then at the end, we are going to close both files. And that's it. So let's go ahead and run this, make sure it works. So you see over here, the file doesn't appear until I refresh by closing this and then open it again. And now you can see the file is here. And it's probably going to do this weird thing where if I click on it, it disappears again. Oh, no, it didn't do it this time. Okay, well, that's nice. So there are a lot of English classes, looks like 31 English classes next semester. All right, so that is everything about writing files. And that was the end of chapter 8 on Runestone. So now I want to go ahead and get into lists, which is chapter 9. So you probably haven't read this section yet, or any of this chapter yet, because the Runestone assignments are a little bit behind. At least I think they are. Maybe I'm wrong about this. But anyway, I might go over some things that are a little bit ahead of where you've read on Runestone. So starting out with basic stuff about lists, Working with a list is really similar to working with a string. There's many things that they have in common, but in a list, you have elements instead of characters. So a string is made up of a bunch of characters that are all next to each other, but a list is made up of elements that are all next to each other, and each element in that list can be any data type. So you can have numbers in lists, you can have strings in lists, you can have other lists in lists. You can have anything in a list. You can have turtles in a list, whatever. And the other difference between strings and lists that is the most obvious is lists are enclosed in square brackets instead of in quotes. And in lists, you have commas between the items. So like down here in this code block, this is a typical example of what a list looks like. It's enclosed in square brackets, and then you just literally just list the elements with commas between them. Okay? So this list down here has a string for its first element, and then another string for the second element, and then it has a float, and then an integer, and then a Boolean. But as far as similarities between lists and strings, there are a lot of similarities. So individual elements in a list are accessed by their index using the same notation as for strings when you're accessing a character. So for example, if I have a list called my list and I want the index 2 element, I use the square brackets and then the 2 at the end of the list name like this. That will return to me the element in the list with index 2, which would actually be the third element. You can also do slicing, just like you do with strings, where you put two numbers with a colon between them. So this would return to you the index 2, 3, and 4 elements from the list. So basically the sublist of the items with index 2, 3, and, oh wait, not including 4, sorry. It always stops right before that second number. So this would include the elements with index 2 and 3, but not 4. And it will actually return to you a list of those two things. I'll show you an example in a minute. Another similarity is you can use the len function to get the length of the list, in other words, the number of elements that it has. And you can use the concatenation with a plus the same way that you do with strings. So just like how you can glue strings together end to end, you can glue lists together end to end using plus. So if you have one list called mylist A and another list called mylist B, you can concatenate them with the plus, and then it'll just be like a longer list that has everything from A and then everything from B. And multiplication operator works the same way as with strings as well. It just makes multiple copies of that list and then concatenates them together. So let's go ahead and look at some examples so you guys get the idea of exactly how this works. So here we have a list called L, and L equals first element, 0 index element is the string ABC. The 1 index element is the string hello. Index 2 element is 10.5. Index 3 element is 751. And then the index 4 element is true. So I'd like for you to actually pause the video and try to predict what is going to print out from each of these lines here. And then restart the video to check what will actually print out, and we'll go over it together. Okay, so let's go ahead and go over this together. So in each of these, I put a little string at the beginning of the print labeling what the line is, because there's so many of them that otherwise you might get confused. Okay, so for the first one, the length of L, this is going to print out the number of elements in L. So there are 1, 2, 3, 4, 5. So this should print out 5. So just make a note here. This is going to print out the 0 index element from L. So in other words, the first thing in the list. So this is going to print ABC. This is going to print out the index 1 element, so the second thing in the list, which is hello. Now this one here, be a little bit careful with this. So this is going to take the index 0 element, which is ABC, and then it's going to do a plus with the 1 index element, which is hello. So this is doing string concatenation. This is doing the string ABC plus the string hello, which, as you guys know, is going to be the string ABC hello. So this is not doing a list concatenation, because when you when you put an index in brackets like that at the end of a list, you no longer have a list, you have an element from the list. Okay, and then similarly here, the index 2 element is 10.5, and the index 3 element is 751. So this is just going to add those two elements together in the way that numbers are added together. So this is going to be 761.5. Now here we're doing slicing. So this is going to take all of the elements from 0 and then stopping right before 2. So the index 0 and 1 elements. And it is going to come out as a list. So this is going to be the list with element ABC first, and then element hello, and then it's going to stop right before index 2. So those are the only 2 elements. Similar here is going to start with the index 2 element, which is 10.5, and then it'll do the index 3 element, and then it's going to stop right before the index 4 element. Now these two, because each of these things individually is a list, this plus here is going to do list concatenation. So it's going to take these 2 lists from the previous 2 answers, and it is going to glue them together. So we're going to have a list that is ABC, and then hello, and then 10.5, and then 751. Okay. Second to last one here, L plus L, that's just going to glue the entire list together. 2 copies of it. So let me just copy paste here. And then we're going to have another one. And there's not going to be square brackets in the middle. It's just going to be one long list like this. And then same deal here. This is the same as doing L plus L plus L. So just 3 copies of the list. And then they're glued together so they don't stop like this. They just have commas, and then it keeps going to the next one, like that. Okay, let's go ahead and run this and make sure all those answers were correct. All right, so that is some basic information about lists, and let's move along to how you can actually change list elements. So unlike with a string, in a string you cannot change characters that are in the middle of the string, but in a list you can do that. So for example, here I have a list called my list, and it has 6 elements: the string A, the string B, the string C, and then integers 10, 20, 30. And I can actually, if I want to, just change one element in this list, the 0 index element. I can change it to be hello, just like this. So I can assign the 0 index element to be hello, and then you can just confirm that this worked by looking at the printouts here. The first printout is the original list. The second printout has hello instead of A. So that is a thing you can do with lists. Another thing you can do with lists is you can append and remove elements. And this is getting into the reason why lists are so useful and why they're really, really, really common in any programming that you do. So a list is something that you want when the amount of information that you're storing can change. So in the example down here, I'm doing an inventory for a character in an RPG game. And I want you to just imagine for a second, how would you actually store the inventory of a character if you had to use a different variable for each item? Because characters can pick things up and put them down, right? They can sell them, they can buy them. If you don't even know, from like a programmer who's designing a game doesn't even know how many items each character would have, right? So it would actually be impossible to do this if we didn't have the concept of lists. Lists allow us to change the number of things that the user has really easily and be very flexible about that. So anyway, appending and removing elements. So the way to add an element to the end of the list is with this method called append. So this is a dot method, and we'll learn some more dot methods on Friday, I guess. But the way you use this particular method is you put the name of the list, then you put a dot, you put the word append, and then whatever it is that you want to add to the end of the list, that element, you put it in the parentheses. Removing elements works pretty much the same way. Name of the list, dot, remove, and then put the element that you wanted to remove. Right? And so one thing to note when you're looking at this code and the way the syntax works is a little bit weird, and we'll talk more about this later, but when you're appending and removing elements, you don't start the line with list name equals. So you're not reassigning the list to a new value. You just call the append and the remove commands. It's a little bit strange because with strings, like if you wanted to change a string to like an uppercase or something like that, you would typically do like s equals s dot upper. But here we don't do inventory equals inventory dot remove. We just directly call the remove command on inventory, and that goes ahead and updates the inventory list in the computer's memory. A little bit strange, and like I said, we'll talk about it more in detail on another day, but just to be aware of that for now. It's kind of like with turtles, how you don't have to like, you can just call like turtle.left or whatever, and then it just turns left, and you don't have to do a variable assignment to make that happen. Okay, so in this example, I have an inventory, apple, stick, torch, key, sword, shield, jar of bees, and I'm printing that out. And then I am appending Flint to the end of that list and printing it out again. And then I'm removing apple from the list and just printing it out a third time to confirm that it worked. So you can see here the first printout is the original inventory. Next one, we've just added Flint to the end of the list. And then on the third one, the list is the same as the second line, but I've removed the apple entry. Okay. So I'd like you guys to go ahead and try that in the next code block. So I've started you off with the same beginning inventory as in the last example, and I'm just printing it out here to confirm what's in it. And I want you guys to add 4 lines of code, 1 to remove the torch, 1 to add a bell to the inventory, 1 to change the index 2 entry to a stick of gum, and then a line of code just to print the list out again and confirm that you did those things. So go ahead and pause the video and try doing that. Okay, so assuming you went ahead and did that, I will show you guys how to do this. So first, let's remove torch. So I'm going to do inventory.remove, parentheses, and then the string torch. Make sure it's capitalized the same way, otherwise it won't work. Then I'm going to add a bell to the inventory. So I'll do inventory.append bell. Okay, so that's going to put the bell at the end of the list. Now to change the index 2 entry, you have to use the technique that we went over up here, reassigning list elements. So I'm going to do inventory bracket 2 equals, and I'm going to change this to stick of gum. And then lastly, I'm going to print out the updated list so it can confirm that my changes worked. Okay, so we see the index 2 entry, which was, well, this is a little bit interesting, isn't it? So actually first I deleted torch. So after I deleted that, the index 2 entry became whatever was next, which was key. So actually key is the one that got replaced by stick of gum, which is why there's no key here. And then at the end, I do have the bell. Okay. So last major concept for the day is looping through lists. So you guys have actually already done this. We were using lists and for loops before we even really defined what a list was. But I just want to remind you guys that you can loop through a list and do things with the items in the list. So in this example here, I'm taking each item in the inventory and I'm just printing it out with the words you have in front of it. So it's a pretty basic thing to do, just print out what's in the list. So you have an apple, you have a stick, you have a torch, etc. Next example is a little more complex. So here I am using the accumulator pattern for strings. So I'm starting off with an empty string, and then for each item in the inventory, I'm taking that string S and I'm replacing S with itself plus a comma and a space, and then the item in the list. So I'm building up the string S from nothing into a list with commas and spaces between each item. And then if I would just do that and not do this line right here, it would actually not look quite right. Let me show you how it looks if I don't do that line. Okay, it'll end up having like a comma and a space at the beginning, which is not what I want. This line right here, S equals S2 colon, this is actually replacing S with the characters that start at index 2 and then all the way to the end of the string. So it's basically trimming off the index 0 and 1 characters from the beginning of S, and just to get rid of that comma and that space at the beginning right there. All right. So this is printing off the inventory in a little more complex way. So for the last exercise for this video, I'd like you guys to try doing this. In the next code block, I've given you a list of grades, and then I've made a new list that is empty, so there's no entries in it, called curved grades. And what I want you to do is loop through the grades list, and then for each grade in the grades list, I want you to append the curved version of that grade to the end of the curved grades list. And so the curving formula is just 10 times the square root of the grade. So go ahead and pause the video and try doing that. Okay, so assuming you did the exercise, here is one way to do it. So I'm going to loop through the grades list, which means I'm going to do 4, and then you need to just put some variable here. You could call it grade, you could call it num, you could call it x, whatever. And then in grades. Okay, and then so x is going to become each grade one at a time. First x will be 70, then x will be 65, then x will be 50, and so on. So for each value of x, what I want to do is append to the end of the curved grades list. I want to append the curved version of x. So to get the curved version of x, I'm doing 10 times x, and then I want the square root of x, so raise it to the 0.5 power, like this. And then I'll just go ahead and print out the curved grades list at the end, just to make sure that I did this right. So let's see if we get the right thing. Yes, those look like the curved versions of the grades. All right, so that is it for today. Send me an email if you have any questions about this. Otherwise, I will see you guys on Wednesday.